Integrated Faith e-learning platform. My name is Mr. Benjamin. This class is mathematics class for primary 4 and basic 4. And our topic this morning is identification and properties of three-dimensional shape. Let me recap the topic again. Identification and properties of three-dimensional shape. Two-dimensional or 2D shapes are plane shapes that have only one face. Examples of two-dimensional shapes are the square, the rectangle, the triangle, the shape of a chalkboard, etc., etc. These are some of the shapes with two-dimensional shapes. Shapes like square, rectangle, triangle, and shape of a chalkboard. They all have only length, breadth, or width, and do not have any thickness. These shapes only have length and breadth, and they do not have any thickness. That is two-dimensional shapes. Two-dimensional shapes only have length and breadth without any thickness. Some common solid shapes, such as we have shapes like cube, cuboid, and cylinder, are known as three-dimensional shapes. Shapes like cuboids, and cylinder, they are referred to as three-dimensional shapes. Three-dimensional shapes have length, breadth, or width, and height or depth. If you want to identify shapes that are three-dimensional shapes, they have length, breadth, height, or depth. We have some of the examples of three-dimensional shapes. We have cuboid. Cube is a good example of three-dimensional shape. Cube of sugar, and with 6 faces, 12 edges, and 8 vertices. Cube has 6 faces or surfaces, 12 edges or side, with 8 vertices or corner. While a cuboid has 6 faces or surfaces, 12 edges, and 8 vertices or corner. And triangular pyramid has 4 faces, 6 edges, 4 vertices. And square pyramid has 5 faces, 8 edges, and 5 vertices. And triangular pyramid has 5 faces, 9 edges, and 6 vertices. Rectangular prism has 6 faces, 12 edges, and 8 vertices. These are some of the examples, diagrams of shapes with three-dimensional shapes. Some of the solid shapes that have three-dimensional shapes. Shapes like this is the diagram of a cube. The diagram of a cuboid or a rectangular prism. Cuboid and rectangular prism, they are the same. They have the same shape. They are three-dimensional. They are referred to as three-dimensional shapes because they have length, breadth, and height. We also have a triangular prism. This is the diagram of a triangular prism. And we also have a diagram of a square pyramid and a cylinder. These are some of the solid shapes, some of the diagrams of the shapes with the three-dimensional shapes. A triangular pyramid also have three-dimensional shapes. From the above shapes, we observe that the flat faces are known as the surfaces. That is, the flat faces, they are known as the surfaces. An edge is a line where 2 faces meet. When we talk about an edge is that line where 2 faces meet. So a line where 2 faces meet is being referred to as an edge. While a vertex is a point or corner where 3 or more edges meet. When we talk about vertex, example 1. What shapes are the faces of A. Cube, B. Cuboid, C. A squared pyramid? So let's look at the diagram of a cube. The face of a cube, so solution. The face of a cube solution. The faces of a cube are square. If you look at the faces of this cube, the faces of this cube, they look like what? A square. Remember, a square has all the sides are what? Equal. So the faces of this cube are square. B. Faces of a cuboid are rectangular. So when you look at the face of this cuboid, the face of this cuboid is having what? A rectangular shape. The face of this cuboid or a rectangular prism has a rectangular face, while the face of a square pyramid is square and triangle. So the face of a square pyramid, if you look at the face of this square pyramid, it has a square shape and a triangular shape. So the face of a cube has what? A squared face, while a cuboid has a rectangular face, and a squared pyramid has a squared and triangular face. Is that taken? If you look at the shape of this cube, it has a square shape. When we talk about square, all the sides are what? Equal. In a square, all the sides are equal. Then, when we look at the face of this cuboid, it has a rectangular face. If you look at the face of this cuboid, the two lengths, remember a rectangle has two lengths and two breadths, and the two lengths are equal and the two breadths are also what? Equal. Is that taken? Then looking at the face of a square pyramid has the face of a square and the face of a triangle. Is that taken? Then we will now move to the net of some solids. The net of some solids. Looking at the board, we'll have a cube. This is the net of a cube. Though this class is supposed to be a practical class, in the sense that you get a cardboard paper. If you are constructing net of a cube, you get a cardboard paper. You take the measurements of the length of the cube, in the sense that all the length must be what? Equal. So if you cut your cardboard paper into this sheet, you get your cube. If you take the measurements, get a cardboard paper, take the measurement. For example, if this length is 3 cm, that means you will use 3 cm all through for your measurement. If you are using 5 cm, you use 5 cm all through for your measurement, and probably you are using 7 cm, you use 7 cm all through for your measurement. If you follow exactly this net shape of a cube, you will get a cube. Then this is the net shape of a cuboid. The net shape of a cuboid. If this length is 7 cm, that means you use 7 cm all through, and the length, if the length is maybe 2 cm, you use 2 cm. If you follow this diagram on the board, it should be able to give you the shape of a cuboid or a rectangular prism. Then this is the net shape of a cylinder. The one I'm holding in my hands right now is the shape of a cylinder. When you fold, you get a carbon paper, cut it into a rectangular form with 2 cycles by side. When you fold the carbon paper, in this form, then you use the 2 cycles to cover both the top and the bottom. It will give you the shape of a cylinder. Then you look for a masking tape. You use the masking tape to hold the edges. Is that taken? Let me explain the cylinder again, because that is what I'm holding in my hand right now. You get a carbon paper, you cut the carbon paper into rectangular form. If you look at this shape, a cylinder has a rectangle. It's a rectangle, it has the net shape of a rectangle and 2 cycles. Get a carbon paper, cut the carbon paper into rectangular form with 2 cycles by side. Then when you fold the rectangle, and if you fold the rectangle, then you now use the top cycle to cover both the top and the bottom. It will give you the shape of a cylinder. Is that taken? Then this is the next shape of a square pyramid. The next shape of a triangular pyramid. Get a carbon paper, cut it into this form. It will give you exactly a square pyramid, and this will give you exactly a triangular prism. Is that taken? This is supposed to be a practical class, so you are expected to get a carbon paper to produce the next shape of some of these solids. Is that taken? Then practical exercise. You are expected to state 2 examples of 3-dimensional shapes. State 2 examples of 3-dimensional shapes. What shapes are the faces of a cylinder? Then question 3. If F, this F stands for faces, E stands for edges, and V stands for vertices. What shape satisfies the following? That is, you are expected to use the initial table. You are expected to use the initial table where the shapes, where the faces and the edges and the vertices of these shapes are given. You are expected to use that table to answer this question. The question states that if F stands for faces, E stands for edges, and V stands for vertices, what shapes satisfy the following? We have edges plus vertices minus face will give 10. So you are expected to fix in the value, pick your value from the initial table. Is that taken? You are expected to do the practice exercise on your own, and remember, the more you practice, the more you become perfect in producing the next shape of some of these shapes. Thank you.